Year 12, let's have a look at question 13 and 14 from exercise 1206. Now, most questions will be at the end. Very, very rarely do we have the beginning. But here's one here. Mila puts aside $20 at the beginning of each month for 3 years. How much will she have then if the investment earns 8% per annum and it's paid monthly? So, as I've said before, please set this up like this. So this is 13. How much will she have at the end of the first month? Well, she puts the $20 in and it's going to earn 8.2%. So 8.2% per annum in terms of months is 8.2 divided by 12. It's per, by the way, that's PA, per annum, per year, per month. What's the interest rate per month? Pump out my calculator, what do we get? 8.2 divided by 12. I hope this is a nice easy number. So we're going to have a repeater. So this is going to be difficult. But anyway, so I'm going to leave it as a fraction and I'm going to divide by 100. So it's 8.2 over 12 divided by 100 because I need it as a percentage. All right. So after the first one, it's going to be 1 plus. Now, if I could round it. I could round that number and go 0.00683 and I get close. But come on, let's be precise. So I'm going to have 1 plus 8.2 over 12 divided by 100. They're just numbers. Don't let them freak you out. So that's how much is at the end of the first month. The second month, at the end of the second month, there's 20 times, I'm going to really write this out. Hopefully you are good at this. 1 plus 8.2 on 12 divided by 100. She put in another Mila. Who cares? It doesn't matter. They've put in another $20 and all of that has earned 1 plus 8.2 divided by 12 divided by 100 again. Well, if I write that a bit better, I'm going to have 20, 1 plus 8.2 divided by 12 divided by 100 squared plus 20, 1 plus 8.2 divided by 12 divided by 100. And this is going to continue on until 3 years, 12 months. So 3 times 12, 36. So I need to go all the way down to A36. And what am I going to have? I'm going to have 20. 1 plus 8.2 divided by 12 divided by 100 to the 36. Because you can see, because I've put it at the beginning, these two numbers are the same. Plus, dot, 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 dot. I'm going to have the same thing from 36, so 35, 34, 33, all the way down till I get to 20. 1 plus 8.2 divided by 12 divided by 100 to the 1. Should have put a 1 there. So if I take the 20 out, I get 1 plus 8.2 divided by 12 divided by 100 to the... oh yeah, better put those in. I'm going to put a big bracket. Come on. A big bracket. And I got that to the 36 plus dot, dot, dot. All of those terms. 1 plus 8.2 divided by 12 divided by 100 to the 1. And I got a big set of parentheses there. So I've got 20. Let's rewrite this the other way. 1 plus 8.2 divided by 12 divided by 100 divided by 100 to the power of 1 plus, that's going to go all the way up to 36. 1 plus 8.2 divided by 12 divided by 100 to the 36. And this is a series. Now, what series is it? Well, A equals 1 plus 8.2 divided by 12 divided by 100. Was it 8.2? I'm losing myself here. 8.2 it is. They had to give us a recurring. I wish they'd given us a decimal that wasn't a recurring. Now my R is the same thing. 1 plus 8.2 divided by 12 divided by 100. And my N is 36. There are 36 of these things. So I'm finding S of 36. And what am I finding? How much she'll have. So A of 36 equals 20 times S of 36. Now S of 36, so this is going to get big and ugly. 20 times A, 1 plus 8.2 divided by 12 divided by 100 times R to the N, 1 plus 8.2 divided by 12 divided by 100 to the 36 minus 1 all over 1 plus 8.2 divided by 12 divided by 100 minus 1. Now remember, I could have rounded and used 1.083, but I wouldn't have got the exact answer, or get rounding error. So it looks hard to enter in your calculator, but it's not. They're just numbers. So here we go. And remember, this line is so important because there's a really big chance that you're going to stuff it up. So have an idea about what it's going to be. $20 a month. So 36 20s. Let's have a think about what 36 times 20 is. That's how many 20s she's put in there, or he's put in there. 720. It's only 8%. Well, that's what? 8% is not a lot. Should be maybe a little bit less than 1,000, maybe 800 or 900. Who knows? So here we go. 20 times. I'm going to need a lot of brackets. Okay. Don't need that many to start with. So I've got a fraction. First set of parentheses. 1 plus 8.2. Okay, here we go again. 20 times bracket, fraction, bracket. 1 plus 8.2 divided by 12 divided by 100. Close that bracket. Whew. Next bracket. And another bracket inside that. 1 plus 8.2. I should have put that as my answer. Oh, that would have been smart. Too late now. Divided by 12, divided by 100 to, oh, too many brackets there, the power of 36, get out of there, minus 1, close that set of brackets, come downstairs, bracket 1 plus 8.2 divided by 12 divided by 100, close that bracket, minus 1, get out to the end, have another bracket. Whew, there you go, $818.7175, so $818.72. $818.72. Now, just if I went backwards, what I would have done, and I should have thought to do, is to go 1 plus 8.2 divided by 100 divided, doesn't matter which way I do it, divided by 12 divided by 100, and go on. Righto, that's my answer now. So I'm just going to go 20 times bracket fraction answer times bracket answer to the power 36, get out of there, minus 1, close that bracket, come downstairs, my answer minus 1, get to the end, close that bracket. I should have done that. All right, so there you go. That is question, I hope that's the answer to question 13. What did they ask? How much will she have saved? Beautiful, and that's the correct answer. Now, the next one, and I want to spend a bit of time talking about this because my big worry is that you're not going to be able to understand tables. Some people had real problems dealing with the tables. And if I look back here, go all the way back to these tables. Because that's so difficult, what I just did is so difficult, they've made tables and they've got these magic numbers in the table. Well, how did they get these magic numbers? How did they find 1% for one period, or 1% for 30 periods, or 6% for 30 periods? They did the formula. They did the sum of the geometric series for that percentage rate. Okay? So if I go back here and get rid of the 20, I should have just gone the other way. Come on. Get rid of that 20. Oh no, because I've changed my answer. If I got rid of that 20, that would give me a number for an 8.2% for 36. That's why tables are limited. They're only limited. They're limited to the percentages that are written in the table and to the time periods that they're calculated to. If you can do the formula, you're not limited. So this is how, and this is what they're asking you to do with question 14. When you use the table, you're using a magic, you're going, oh, the annuity value. The annuity value is this magic number. So when you're using a table, you go, oh, the future value equals the present value, or the investment, the payment, because it's an annuity, times this magic number from the table. It's in the table. And if you need to find the future value, you just divide by that magic number. And what is that magic number? That magic number comes from this. That's how the table is generated. Now you could go and generate that number. That there is a magic number for 8.2% for 36 periods. 8.2% per month. All right? So what they want to find in question 14 is they want you to find $1, because the tables are based on $1, for 19 years, 70%. Find the future value. 19 years, 7%. So 19 years, 7% per annum. So go all the way back to this table. It'll come up shortly. All right, 19 years. So this one, 7%. This one, and what is that? Just make sure I'm in the right column. 37.379. 37.379. Come on. Where's my screen gone? There we go. 37.379. Come on, let me get back down here. So here's question 14. A, from the table, 37.3790, I think was the answer. Right. So, and what they ask in the question? Find the future value of $1 for 19 years. So the future value, that's my magic number. My future value equals my present value, $1, times the magic number, 37.3790, which is $37.3790 and $37.38 because we'll round up. But in part B, prove that this table value is correct. Well, all I've got to do in part B is get this series going. All right? So my future value equals 1 plus. Now, am I putting it in at the end? Come on. End of each year. So I'm going to use my A1. A1, at the end of the first year, I got a buck. At the end of the second year, I've got 1 times 1.07, 7%, all right, plus a buck. And I'm going to jump now, 19 years. After 19 years, I'm going to have 1 times, now look at the numbers here. That's a 1, I've got a 2 and a 1, I've got 1 less. So 1.07 to the 18 plus 1 times 1.07 to the 17, ... Be careful, I'm going to have a 1 at the end, plus 1 times 1.07 plus 1. Now, take the 1 out. Doesn't make, take the 1 out. I don't even need to take the 1 out, but anyway. Write it in the reverse order. So I'm going to write 1, 1.07, and so on until I get to 1.07 to the 18. So 1 plus 1.07 to the 1 plus ... plus 1.07 to the 17 plus 1.07 to the 18. How many terms are there? 1 plus 18, 19 terms. So here's a series. A equals 1, R equals 1.07, and N equals 19. Now, equals 1 times, I'm just going to work out S of 19. So 1 times A1, 1.07 to the 19 minus 1 over 1.07 minus 1, away we go. So I don't need the 1 out the front and I don't need the 1 in front of the bracket, so I've just got 1.07 to the power of 19 come down from there, minus 1 over 1.07 minus 1. 37.37896. Right, I'm going to write that in because it's going to show that I know what I'm doing. So 37.38796, 38796. I'm going to write all my stuff on my calculator, 479. Now, the table only goes to 4 decimal places. 1, 2, 3, 4. So it's going to there. So if I round that, 37.38. Sorry. 3. Have I written that down right? I wrote it down incorrectly. Sorry. 37.3789. 789 6479. 6479. And they only go to 4 decimal places, 1, 2, 3, 4, so they go to there. So 37, and I don't write the 8 yet because that 6 is going to round that 9 up to a 10. So I'm going to get 9, I'm going to get 0, which is the number that was in the table. So that is how you do or you prove it. All right? That's how you prove that. And that magic number, please know that that magic number in the table comes from that geometric series. And they've probably used a spreadsheet to calculate them all because you can just change one of the numbers and put in a table and it'll just spit it out. Okay, so that is exercise 1206, questions 13 and 14.